Yes.
Yeah. Now, uh, so today we are going to discuss about the Snowflake architecture. So this is the Snowflake architecture, guys. This is the Snowflake architecture, and then it has three layers. Okay, one is database storage layer, another one is query processing layer, another one is cloud services layer. Okay, these are the three layers we have in the Snowflake architecture. Okay, and this is important, guys. This is very much important topic, and you will get the interview question also. You will get the interview question on Snowflake architecture for sure. Okay. So we'll start with the database storage layer. So what is this database storage layer? Actually, whenever you load the data, whenever you load the data into the Snowflake target tables or Snowflake tables, data is going to store in a database storage layer only. Okay. How the data is going to store in the Snowflake, that we will discuss now. Suppose if I open the image, 1 second. Let's consider table T1. Table T1, you load the data into the table T1. The data is going to store in the table T1. Whenever you load the data into the table, any tables, data is going to store in a multiple micro partitions. So multiple micro partitions. Micro partition is the storage component in the Snowflake. Whenever we load the data into the tables, data internally, you can't able to see these things and all. Internally, data is going to store in the multiple micro partitions. One micro partition size is 500 MB. So based on the data volume you stored into the tables, according to that, the number of micro partitions will be allocated to the your table. Next, once the data is stored into the micro partitions, once the data is stored into the micro partitions, all these micro partitions related information will be written into the metadata tables. Do you know what is the meaning of metadata tables, guys? What is metadata? What is metadata? Others, Nitin.
No, sir. Don't have that.
Yeah, metadata means uh, suppose, yes, data about the data. Suppose, see, you have a list of the objects in the stored procedure. Suppose you have a stored procedure, function, table, schema. If you create a table, okay, that information written into the system tables. So when the particular table is created, okay, when it is modified, when it is created, who is created, all these things will be written into the metadata tables. So here, whenever you load the data into the table, the number of micro partitions will be allocated. The number of micro partitions will be allocated. Okay. So let's see here for this table T1, micro partition 1, micro partition 2, micro partition 3, and then micro partition 4. These 4 micro partitions are allocated to the your table T1. So metadata means internally it will maintain that. So for this T1, these many micro partition 1, 2, 3, 4, those 4 micro partitions are allocated, and in each micro partitions, how many records are stored and what are the values? Minimum value and then maximum values will be stored into the metadata tables. So what is the advantage here? What is the advantage to store the micro partition details of the particular table in the metadata table? Now, suppose let's consider if you write a one second guys, one second. Yeah. Suppose if you write a query, select star from table T1, where name equal to y. Example, where name equal to y. Y is having a 1 record and y is having a 2 records. Okay. Select star from table T1, and then where name equal to y. So for this condition, you have 2 records. Now, what it will do? Snowflake, with the help of the metadata tables, instead of scanning the all 4 micropartitions, to bring the data for you, it is going to scan only a specified number of micropartitions wherever the value y is available. So in case of these 3 micropartitions, micropartition 3 is having a y, micropartition 4 is having a y. So instead of scanning the 4 micropartitions, it is going to scan only a 2 micropartitions and bring the data. So by doing this, it is going to save the execution time of your SQL. Instead of scanning all the micropartitions, it is going to scan only 2 micropartitions. By doing this, you can able to see the very good performance improvement of your SQL. So in this case, you have only 4 micropartitions, and then it is going to scan only 2 micropartitions. Maybe in this scenario, you don't see the much execution time difference. But if the table is having a huge data, like gigabytes of data, and then you are writing a query against your table and implementing some conditions, in that scenario, you will see the big difference of execution time. So that this is the one of the advantage by storing the metadata information in the metadata table. So next one is, in the Snowflake, data is stored in a column format, not into the regular format. See, you load the data into the T1. If you query the table, select star from table T1, then you will be able to see the data in the combination of rows and columns only. You will be able to see the data in the form of combination of rows and columns, but internally data is going to store in a column format only. Suppose here you have a column type, name, country, and then date. So see here, your data is stored in form of columns only: type, name, country, and then date. First record 2A UK 11/2. 2A UK 11/2. Data is stored in form of column format, not in a regular format, rows into columns. What is the advantage here? To store the data in a columnar format or column format. Suppose see here, First record is available in the only one micro partition. See, 2A UK 11/2, 2A UK 11/2, and then fine. Second record 4C SP 11/3, 4C SP 11/2. So each record is available in a one single micro partition only, because data is stored in a column format, not in a traditional format. If the data is stored in a traditional format, this one record itself split it into the multiple micro partitions. This is again unnecessary reading the data. This is again unnecessary reading the data. Okay, as each record is going to reside or sit in a only one micro partition. To bring that particular record, it is going to scan only a one micro partition instead of all these four micro partitions. That is one of the major advantage here, to store the data in a column format. See here, the same record, if the data is stored in form of the rows and columns, and this record may split into the two micro partitions, because you have four columns. Those four columns are split into the two micro partitions. In that scenario, if you have a huge number of columns for one record itself, it will split into the multiple micro partitions. To bring the data from the table, then it needs to scan the multiple micro partitions. Again, it is time killing, time taking. Instead of that, they have changed the architecture and then stored the data in a column format. Store the data in a column format. Okay. In that scenario, then it is going to read only, suppose if you want to read the last record is available in the last micro partition. So in that scenario, it is going to read from the only one micro partition instead of the multiple micro partitions. So this is one more scenario. And again, in traditional database, okay, in traditional database, if you see, there are indexes in traditional database. In this Snowflake, you have a, instead of indexes, you have a cluster key. If you create a cluster key on top of any column, data logically sorted, data will be stored in a ascending order. I will tell you. See, if you create cluster key on top of this name column, data is sorted here. Earlier, data is not in a sorted format, A, C, B, like that. But if you create a cluster key on top of this name column, data logically sorted, and then same sorted data is going to store into the multiple micro partitions. Now, the value y are available in a only one micro partition. Only one micro partition. Earlier, these two records are split into these two micro partitions, but the value y, now value y is available in the only one micro partition. To bring these two records, it is going to scan only a one micro partition and bring the two records Okay, so this is all about the storage layer in the Snowflake. Once again, see, storage component of the Snowflake, load the data. Data will be stored in a continuous micropartitions in a compressed and then optimized way. Whenever you load the data into the Snowflake, data is compressed and then store the data into the micropartitions. Size of each micropartition will be the 500 MB. Data will be stored in the column format. It is going to store both the structured and then semi-structured data. So now tell me guys, the storage layer is clear or not clear? Yeah. Or you have any gaps? Others? Nitin,
Clear, sir.
other guy, NT, Etinosa.
Oh, yes, sir.
Okay. So where are you from, Etinosa?
I'm currently in the US.
Yes. What's your background?
I'm a software developer, Java software developer.
Sorry.
I'm a Java software developer.
Okay, Java software developer. What about
Yes.
Nitin? What's your background?
Sorry,
Nitin.
I didn't catch that.
No. I'm asking Nitin.
Okay.
Sir, I am a senior support engineer.
Sorry.
I am a senior support engineer working
Uh-huh.
on PLC core.
Oh, what can PLC code? Then it's good actually. Now this storage layer is clear, right, guys?
Yes. Oh,
The storage layer is clear, right?
Yes, it is.
yes, sir. Yes.
You're clear and you don't have any queries, then we'll start query processing layer discussion.
So it's clear. Storage is clear. We can start with the query processing.
Yeah. Next is query processing layer. See, query processing layer is the it has the virtual warehouses. Virtual warehouses means hardware resources in your Snowflake account. See, hardware resources are provided in the Snowflake virtually, not a physical components. So how you are creating a table schema like that, you can create virtual warehouse also. This is also one of the object in the Snowflake. Okay. Once again, I'm telling you, in the Snowflake, hardware resources are not available in the physical components. Hardware resources are provided in a virtually in form of virtual warehouses. You are going to create a virtual warehouses. How you are going to create a table schema like that, you are going to create a virtual warehouse. The thing is, the virtual warehouses will be provided in a different sizes. Small size, medium size, large size, extra large size, extra double extra large size like that. See, you can say computing. You can say computing these virtual warehouses. Compute means what? Hardware resources. Hardware resources. Without these virtual warehouses, you can't run anything in the Snowflake environment. Do you agree? Without the hardware resources, can you execute any statement in the database in on-prem or wherever it is? Tell me guys. Without the hardware resources, is it possible to execute? Is it possible to execute any SQL statements in the
No.
database?
No.
No. Like that. So this is the virtual warehouse. These are the hardware resources. Without these virtual warehouses, you can't execute any statements in the Snowflake. Now, in the on-prem server, hardware resources are shared resources because see, they will configure, they will build, they will set up the hardware resource with the one server, and then remaining client machines will access that particular server. Remaining client machines will access that particular server. So for that server, hardware resources are configured. So to access that server, all the client machines are utilizing that same hardware resources only. So that hardware resources are shared across to the multiple clients. So what is the problem there? Because as you are accessing the hardware resources, single hardware resource, and then it is shared to the multiple clients. Because of that, you may get the performance issues, and sometimes you don't get the any response also because if the hardware resources are outdated. So to avoid that, in this cloud data warehouse, Snowflake cloud data warehouse, they have introduced you can able to create a multiple virtual warehouses according to the your requirement and then based on the projects. Suppose let's consider your organization is having around 20 projects. Those 20 projects are accessing a same Snowflake environment. So in that scenario, instead of accessing the same hardware resources by the 20 projects, they have provided, Snowflake has provided the option to create the multiple virtual warehouses. Now, you can create the 20 virtual warehouses and assign each virtual warehouse to the individual team. Now, individual team or individual project can be able to access their own virtual warehouse, and according to their project requirement, they can create this virtual warehouse with the different sizes. See here, virtual warehouse size X small, small, medium, large, X large, double X large, like this. We have a virtual warehouse with the different sizes. See, based on the your requirement, you can create virtual warehouse with the different sizes, and then each project can be accessed. Sorry, each project can be accessed their own virtual warehouse. That is nothing but each project is utilizing its own hardware resources. There is no dependency between the one project virtual warehouse to another project virtual warehouse. What is the advantage here? By consuming the individual virtual warehouse, because each project can get the benefit of this virtual warehouse and see the better performance improvement in all the tasks, whether you are loading a data, reading a data, whatever it is, you are utilizing your own hardware resource with your virtual warehouse, and you can able to see very good performance improvement in all the operations. And second thing is, based on your requirement, you can create your based on your requirement, you can create your own virtual warehouse with the different size. See, you have project one, based on their requirement, they can create the small size. Project 2, they can create the medium. Project 3, they can create the large. Project 4, they can create the small. Project 5, they can create the medium. Project 6, they can create the large. According to their requirement, they can create the virtual warehouse size for their project with the different sizes. And they will consume or they will utilize their own virtual warehouse. What is the advantage? What is the advantage to create the different sizes? Simple here. If you create the virtual warehouse size, okay, and started utilizing that virtual warehouse, it is going to generate the number of credits per hour. If the virtual warehouse is with the small size, it is going to generate the 2 credits per 1 hour. If you create with the medium, then it is going to generate the 4. If you create the large, it is going to generate the 8. Same in your house, how you are consuming electricity in form of number of units, and how you are going to pay the electricity bill based on the number of units. Same thing here, also you are going to pay based on the number of credits. For 1 credit, these many dollars. For 2 credits, these many dollars. That pricing part we will see as part of our regular session. I am going to explain you how the pricing part is going to happen on top of your Snowflake utilization. So, based on your requirement, you are going to create the virtual warehouse with the different virtual warehouse size, so that you are going to utilize your Snowflake account with the proper way. So this is all about your virtual warehouse. Once again, see, this layer is a hardware resource to the Snowflake. To load the data, process the IO request, hardware resources are required. Okay. Yeah. So one main important point is, suppose let's consider you have created one virtual warehouse with the medium size, and then you have started using your virtual warehouse in your project. But in normal scenario, this large size is enough for your project in normal scenario. But in the peaks time, suppose if some ETL jobs are executing and those ETL jobs are sharing the data here and there, reading the data, loading the data, reading the data, loading the data in between the ETL tool and the Snowflake. In that scenario, in the peaks time, your large size virtual warehouse is not sufficient. Not sufficient because there is a huge load. Multiple ETL jobs are running, consuming the your 100% 100% your virtual warehouse size, your virtual warehouse. In this scenario, you may be seeing the little bit performance issue in the ETL jobs. So in that scenario, they have provided there is a option in the Snowflake. Immediately you can increase manually. You can increase from one size to the another size to speed up your tasks. Once the tasks are completed, and again you can go back to your original size and then set that original size. Suppose initially your virtual warehouse is with the medium size. If you are seeing a performance issues, then manually you can increase to the large size without stopping the any operations, without impacting any operations. Increase the you can manually increase the large size. That is called as a scale up, scale down, scale up. Scale up is increasing your virtual warehouse size from one size to another size without stopping any operations, any process, to increase the performance of your operations. This is the one option you have. Second option, you can create the virtual warehouse. We will see all these things, how we are going to create, how we are going to increase everything. I am going to show you as part of the regulation. Again, you can create the virtual warehouse with the another option. Manually, you no need to intervention to increase the one size to the another size. Automatically it needs to take care. Whenever the load is happening on your Snowflake, internally it will calculate. If the existing resources are not sufficient, automatically it is increasing to the next level, next size, and then execute all your request and complete all your request. That is also one of the option we have in the this query processing layer. So that is what I mentioned here. See, two types of virtual warehouses: single virtual warehouse and then multi-cluster warehouse. The single virtual warehouse, manually you need to increase. This multi-cluster warehouse, automatically it will increase. We can create these things and all we will see. So multi-cluster warehouse, automatically it will increase the resources based on your requirement and then complete all the requests on time. So a single virtual warehouse, you need to increase manually. So that is one of the option here. So this is all about the your query processing layer, guys. This is clear or not clear? Guys, clear or not clear?
Yes, sir, clear.
Others?
Clear, sir.
Yeah. Next, this is cloud service layer. This cloud service layer is the important layer and the top layer in the Snowflake. Without this cloud service layer, your Snowflake will not work. Without this cloud service layer, your Snowflake will not work, because I mentioned this is the top layer. We'll see why it is the top layer. Why it is the top layer. For very first point is, as a user, if you log in into the Snowflake account, the very first layer is cloud service layer. Cloud service layer will check that whether the submitted or trying to log into the account valid user or valid password or not. It will cross verify at the cloud service layer only. Suppose see I am a user, I'm trying to log into the Snowflake account. Whenever I provided my username and then password, that credentials details will be checked by this cloud service layer. If everything is valid credentials, then this cloud service layer will allow me to log into the Snowflake account. And second thing is, based on the user level, whatever the privileges he or she has, according to that, this cloud service layer will allow to that particular user to perform those activities. I have a limited privileges, then this cloud service layer will allow to perform the limited actions. If I have a super user access, then this cloud service layer will allow me to perform all the activities. That is the very first point. Second point is, suppose let's consider guys, you have submitted the IO request. What is IO request? Guys, what is IO request? Yeah, IO request is input and then output request. Your input and then output request. You are submitting a select statement, that is input request, and you are getting a output from the database, that is output request, that is IO request. Whenever you submit IO request to the Snowflake, the cloud service, the very first thing, cloud service layer will accept your select statement, and then it will scan your select statement. If syntactically everything is fine, then that select statement will pass to the next level, which is query processing layer. The shootable result is available in the cache memory. If the shootable for the select statement, if the shootable result is available in the cache memory, then that result will pass to the cloud service layer. The cloud service layer will return the result to the end user. If the result is not available in the cache layer, then the request will pass to the database storage layer, where the physical data is available in the storage layer. This storage layer will return the data to the cloud service layer, and then this cloud service layer will return the result to the end user. This cloud service layer take the responsibility end to end of the IO request. If you submit the any query to execute, the cloud service layer responsibility and then take care end to end, receiving the request, checking the request, and then passing to the next layer, and then retrieving the result, and then returning to the end user. End to end, this cloud service layer will take care. This is one point. Other point is, and the user is submitted the data load request to the Snowflake account, and then it has started the inserting the data into the or loading the data into the particular table. Until the data load is completed successfully, this data cloud service layer is taking care everything. What is that? Suppose let's consider, while loading it, you have 1,000 records and already inserted the 500 records into the table. The rest of the 500 records are need to insert. Unfortunately, your Snowflake account is closed. So 500 records are not inserted into the table, and which is not a meaningful data load request, because partially data is loaded, remaining data is not loaded. So in that scenario, what this cloud service layer will do, it will roll back all the already inserted 500 records, because if 1,000 records need to insert into the data, 500 records are inserted and remaining 500 records are not inserted. In this scenario, that is not the meaningful data. That is not the meaningful data. Okay. So if only all the records are inserted, completed successfully, then only all the records will be written into your Snowflake. So that is one of the responsibilities of your cloud service layer. Okay. And second thing is, it will also taken care about the security and what are the object user can access, what projects users have, everything based on that. This cloud service layer will allow the particular user to perform the activities. And metadata storage. We spoke about the metadata tables. All those metadata tables are handled or taken care by cloud service layer only. So this is all about your Snowflake architecture, guys. Now tell me, you are clear? You have any gaps? Clear or you have any gaps? Others?
Clear,
Nitin?
clear, sir.
Yeah. So tomorrow I am going to stop for the today's session. So tomorrow, what we will do, we will start to create the Snowflake trial version account and then explore the options are available in the Snowflake, and then from there start working with the Snowflake activities. So who is not attended for the last 2 seconds, they can take the recording video and then go through the recording video and proceed further. So we will connect the same time by tomorrow at 6 a.m. 6 to 7 a.m. IST. And one more thing is, maybe institute people allow for the free demos 2 to 3 sessions. Maybe they are going to change the link by tomorrow because 3 sessions are completed. So that try to make the registration issue as soon as possible by today. Okay. And once you make the registration, then if they change the link, you will get the updated link for your sessions for the next sessions. Okay, guys, clear?
Yes,
Yes.
sir.
Yeah. By tomorrow we will meet, guys, and we'll start with the remaining sessions. Okay. Thank you, guys. Have a nice day. Bye bye.
All right, bye.